Hello, everyone. And to have this seminar on a Sunday evening on Father's Day, first of all, happy Father's Day to all the fathers who are attending. I assume this is going to be recorded for the fathers who are celebrating tonight. Anyway, welcome to everyone. I'm quite excited to be here. Now that I saw the pictures, I regret I don't have the opportunity to be in person with all your members, but I look forward to the first opportunity. Delving into the topic, this year has been quite a year, and our perceptions and paradigms are being challenged all the time. But now, more than ever, pandemics, riots, at least here and all over the world, killer hornets. Let's see what else is going to come. So a lot of changes are happening around the world, a lot of changes around us, and many revolutions in all sectors of life. And now our life per se is put at test, and this notion of risk is being challenged, of course. So I'm just wondering if I should wear this when I'm going to the grocery store, or when I'm going to get on a plane, or if I even get out of the house. But is this really the way in which we want to embrace the new normal? So if we're coming from a risk perspective, so risk is kind of an aversion to danger. It's the probability to be harmed. And if that is high, I don't want it to happen. So what you see here is a defensive posture. So actually, trying to avoid risk is a defensive attitude, and we can change that. But before this, I want to tell you that I'm working with the World Economic Forum, and we have every year a global risk report. So you see here, the pandemic was number 29 last year, and now obviously for 2020 it's come number one. So these things are always changing. So we cannot actually control them. We cannot even anticipate or classify them in terms of which is more urgent. And what is even more interesting is that most risks are interdependent. So it may be a better idea to look at what we can do from a more offensive attitude than defensive. And having worked with many emergency responders in many applications, 9/11, Katrina, you name it, I learned from them and from the respective events that no plan survives contact with a disaster in the making. So we have to actually accept risks that are like an integral part of the equation. We cannot eliminate risk and uncertainty, but what can we do? We can create a sort of immunity for ourselves, for our organizations, so that we can actually live with those uncertainties. So how do we create a resilient world, a resilient life for ourselves, as well as for our enterprises? And you will see that this notion of resilience actually applies to many things. Especially from this perspective of interdependence and networks. And this is what I want to focus on today. Um, well, but of course, let's see what is resilience. So in terms of systems, a system is resilient when it can absorb sudden and external changes. Resilience is very connected to the concept of robustness, which in terms of an organization, robustness is the capacity of an organization to reorganize over spatial and functional scale. So for example, airlines reorganize quickly so we can keep our business going and keep our passengers healthy. So another very important concept is resilience governance, which refers to this vulnerability handling. So that is, if we can detect in advance where is our system vulnerable, we can prepare and strengthen the system in those critical points. And for example, yes, in here close to where I live, barbershops had to be open already in early April when the pandemic was still rising for some essential workers, which were, they had this maintenance grooming standard at work, and they really needed the barber shops. And of course, the businesses were happy to have them. However, how would they receive them without putting their lives and the lives of the barbers themselves in danger? So, there are some rules by which they could strengthen those. And you can see these rules here on my screen. So this is just an immediate example of how we can see resilience at work and actually vulnerability handling at work. So resilience in this regard is the ability to bounce back. And you can take notes for this chart here and maybe do this exercise at the end of my talk for yourselves, for your businesses. It's so-called the 4 Ps. I'm not going to read them to you, but I believe that William can share this slide. I will send it to him and he can share it with everybody who was registered for this seminar, and as well as his members. So of course, one feature is remote work, which is now in vogue, from medical doctors who send their robots to us. And actually, this is a real application of General Electric. It's the latest. I mean, this robot is kind of known, but now medical doctors are sending them, and you can set a sample here and send it back to them, and they can do that testing. Of course, this kind of remote work and virtual presence capabilities, they have been present for a long time. At least the Department of Defense was using them, especially for them having the personnel deployed in the field and then needing to meet. But now such capabilities are used much more, as well as collaborative tools. This is Miro from Adobe, which is really an amazing collaborative tools. Virtual offices, as well as virtual classrooms. You put your 3D glasses and you can find yourself at your workplace in your office while you, in fact, are working remotely. Ford, in April also this year, they have turned to VR to keep their vehicle deployment on track. And it's not only the vehicle design, but we can do vehicle testing as well as inspections remotely now due to technology. And this is the topic of my talk, actually. How can technology make our enterprises more resilient when it comes to continuity of work in the wake of unexpected interruptions? So this is how the workplace looks like for many of us, actually, in these days, but even for people who are working hands-on, and they can do that now because we have such technologies. The cars, yes, can come to us in their virtual form, and with the correct information, they can even start to talk to us and tell us, well, the engine has this problem, or I can diagnose them remotely, simply through this digital capability. So now with the smart twin of the world, as well as the digital law, which we can embed in smart contracts on blockchain, we can have these virtual capabilities to do a lot of work at home. So when it comes to the cars, we need a few ingredients here, and this is not a course about blockchain, but I just want to say that smart assets exist. They, we have the properties for them, identity history. If we have any blockchain people on this call, you must know that we have now programmable assets, and we have contracts for them and rights for them, and so on and so forth. When it comes to grocery stores, seamless accounts, we do not need the people at the counter to actually be there anymore, because all these payments can be seamless. They are already, these are implemented in China, for example, but now they will become more and more pervasive. So we can avoid interaction, because this is what is going to save lives. This is resilience in our day. Another important application is, and this also existed before, but now it can be used even more so, because such simulation models for effective capacity for example, in this case, storage places, can be used to allow automatic robots and automation in those storages to actually manipulate all the goods. But as well, through simulation modeling, we can reorganize the storage itself. So to make sure that when people are coming, let's say this is from Costco, when people are coming back, they, the items are, as well as people's way through the store, can be marked so they keep distance from each other, as much as possible through simulation modeling, scientifically determined what would be the distance between them, how should they move, where would the goods be placed, so not everybody is going in one place, and so on and so forth. So there's a technology, I do not know how many of you are aware of this, which is called spatial contract, which enables actually a good to be recorded not only with the usual ingredients in it as a data, but also with regard to its location in a storage or everywhere else, and when it's moved from a place to another, also the location to be changed. And that is absolutely crucial for automation. Now we can have robots prepare our goods and take them, as well as organize our storages just by themselves through programming, because now we can have this technology, a spatial contract and spatial rules. There's much to say about that. Applications are in supply chain management, asset management, and so on and so forth. This is, again, not the topic. This is just hinting that we have technology to do that, and and automation definitely can help. So I was mentioning that we have, we can use the robots to load the goods, let's say, in the trucks, and then the trucks can go to the grocery store or can go to somewhere else to deliver, but then automatically the payments are being made when the goods are delivered, and of course everything done on blockchain and with artificial intelligence. So convergence of technology can be very useful. But one more interesting example here, and this is what I'm working on with Singularity.net, are these nurse robots. So we, as you know, Dr. Ben Goertzel is the creator and the brain behind Sophia, the first citizen android. Now Sophia is becoming a nurse. And so we, of course, immediately adapted our work to the needs of the pandemic. And so robot nurses are not a dream anymore. They are ready to go into hospitals. Obviously, it's clear that they can work 24/7. They can record a lot of information without any error about a lot of patients and deliver the right treatment at the right time. So they are very reliable. One can, I don't want to say much, and I know this is very controversial, but can trust them maybe more than a human nurse. But on the other side, the human nurses are, with the COVID-19, it's better to direct them to other patients which are less infectious. So this is a true blessing. But in order to deploy that, we need, again, a lot of technology. So the technology itself requires other technologies to be deployed. So the robot nurses, as well as, of course, the ambulancing, rerouting, a lot of artificial intelligence involved here. So when I was mentioning what we need for this, we need to give them some legal personality, for example, in which if they make an error, so where is the blame? Will we be blamed as the creators of the robots or the robot itself? This is, again, a question which is also asked about the autonomous cars. So if the car has an accident, who is to blame? And that is, the answer is given through this legal personality, which was actually a concept introduced already in Malta by the Malta Blockchain Committee. And there's a whole paper. I can give 10 talks about only this. However, there are a few ingredients here, again, which one has to think about when they think about unleashing robot nurse in the world, and not only, but also AIs, autonomous cars, scanners, and so on. So people and machines now, people and things start to cooperate and to interact much more, even than before, because it's needed. Before the pandemic, I just remember I started the first international conference of telework about 15 years ago, when people were asking, tele what? What is telework? And now it's just, here we are doing it right now. So I was talking about this, the people and machines. I call that personally social-technical combinatorics. So these are these adhocracies, these communities, people and things coming together to accomplish something from the bottom up. And this is challenging, of course, the structures which we already have in place, the top-down structures that can, of course, incentivize these groupings and communities. However, sometimes they act more as a barrier to innovation. So at this time, because of technology, people can group and create things much faster. And this has proven also amazingly effective also in the pandemic, and I will give you several examples. But before this, I'd like to clarify a few things. So this is a crash course in network science as it relates to resilience, and this is, that's the only time I have, and probably I even do not have this time. But okay, so there are a few concepts which I'd like you to remain with. So if we talk about networks, networks have a function. Usually they have a function. That's why they are. So it can be and transportation networks, information, material, energy, people. Then there are flows, which are work, material, energy, cars. When we talk about networks, in the context of robustness, these flows can lead to cascading failures, and the failure of so-called, as I was mentioning, those vulnerabilities, which in network language are called critical hubs. And relating network topology to network properties is essential. Well, this kind of relation between network topology and network properties is translated into a matrix. And that's how we, for example, if the property is resilience, yes, then we can go into this, and it's called connectivity matrix. So this topology can be translated into the dynamics on those networks, which can reveal, at least through simulation, thanks God, before the collapse of the system, can reveal those vulnerabilities so we can take measures. So this connectivity matrix, of course, I can send you some papers. It's all mathematics here. So, and concepts like degree distribution, resource exchange across links, and so on and so forth. But the idea is that we can control this, the flows on the networks. We can redirect them so that they do not collapse, so that they avoid the critical hubs, or we can strengthen those critical hubs if we have this kind of information, and then we can simulate. We can tune input attributes and so on and so forth to maximize robustness. So as such, yes, topology and this concept which I mentioned to you before are very important in the simulations which I'm referring to. I referred to them before, but also I will refer afterwards in my talk. So the question is, how does flow affect structural change, and how does this affect the network properties, aka one property being robustness? So once we ask that, then we can go and look at how to achieve this robustness. I already told you that, but I just want to repeat because it's quite important. So we can write the protocols in case, for example, on the internet network, there are protocols, but there are protocols also for safety in enterprises. So protocols are, extensive concepts, but they are specifying the control strategies for managing the flows, which can be data, people, packets, material, energy. And the protocols are creating barriers to cascading failures. So that is how it works to induce robustness in the networks. And of course, it depends from network to network. So it is John Doyle who has done actually this comparison between biology, and here we come back to the first idea about robustness, which I mentioned. So it's now an offensive, it's like an immunity of our system and of our enterprises. Because in biology, the genes code for sensors and actuators in the same way in which we actually are designing this robustness in artificial networks, because the purpose of the genes is to keep us alive, and therefore to make us the most robust we can. So the cells have robustness intrinsically from how they work. And it is John Doyle, the famous Caltech professor, who actually has seen this parallel. And his work is actually seminal in this regard. So I am a great fan of Doyle and a colleague. I worked with him with the NSF when I was a Canada Research Chair. So we were pioneers in what he calls cyber physical systems, and I call socio-technical combinatorics. And so as such, yeah, so my work is mirroring very much John's work. And then there's Brian Saucer and John Boardman, who wrote this book, System Thinking, in which they were looking also at networks, but at networks inside our organizations, and looking at these complex social ensembles and how the innovation emerges in our organizations, and how we can actually foster that innovation in organizations, also through a network science. So how do we create the capacity for self-organization so it reveals innovation in organization? This is another question, and of course this image is a metaphor of that. You need ingredients such as connectivity, belonging, autonomy, and so on and so forth, diversity. But I will come back to the concept. Before this, I want to look at what's happening now with the pandemic and how actually the social network operating system is working to create a resilient society in the face of this threat, which we are learning more and more that it's not going to go away tomorrow, and we have to learn to actually live with it and survive it. So maybe many of you know about Chef Andre with his COVID-19 response, in which he not only is saving the restaurant industry by giving them jobs so they can deliver meals to hospitals and to emergency responders and to the poor and to those who need, to the elderly. So he created this World Central Kitchen movement, I would call it, in which at the same time, yes, creating this social movement, but he is also rescuing our economy, at least the restaurant industry. So he is staying positive. Here you can see him on the Late Show. Others are creating solutions for the elderly, so they do not need to go anymore in those care homes in which they practically are condemned to death, as we all have seen. I mean, my heart is really bleeding. So Age Well, for example, is a peer-to-peer care delivery model in which elderly people who are more capable, they go to their peers at homes and take care of them, and they support each other. So it's a support system that will take them away from those dangerous places, especially now when they have to really live isolated to stay away from the danger of infection or getting infected. And another example, which is now adapted from another, from Hurricane Katrina. So the social network, SOS Shell.network, you can find it. It's here. So actually, John Cole has started this network during Hurricane Katrina, also like a resilient thing. So people can rent their boats and can actually exchange or go and rescue other people before the emergency responders and FEMA would come, because we all know that they always come too late. And as such, now he's adapting it to COVID-19. He has, you can find on his website some very, very interesting applications in which he brings the world together and empowers them to make positive change. So as I was mentioning, there's this paradigm shift from top down. We go now to bottom up, and some amazing things are happening while our top down systems are being challenged because they are, and they have always been, too slow. So these new modes of production are causing a change in equilibrium. So they are now not institution-centric, but person-centric, and they are effective and they work. And so it's no longer from place to place. It becomes from person to person. So this peer production, which already decentralization and blockchain was bringing to light, from person in job to person best able, from, of course, many other changes. But the question is, of course, that our institutions are threatened by this. Speaking of, they are not resilient enough to not be challenged really deeply by these innovations. And it would be a good idea for our institutions if they can harness themselves this social network, such social network operating systems, which are linking the right people at the right time, at the right place. So these are not absolutely new ideas. So the Robin Chase, who is a friend of mine with who I've worked on this, on a few books actually, but also on this movement from Bitcoin to Burning Man and beyond, she wrote a book, Peers Incorporated. So she is the CEO and founder of Zipcar. I don't know if you know that. So in that book, she actually created some rules for how we can look at institutions and at organizations. And if we can actually create the rules for a bottom-up social innovation organization like those which you have seen before, it turns out that you can. And also Michael Albert, who I worked with very intensely on many defense projects, he wrote the book Power to the Edge, but then he wrote Parecon, this participatory economics, in which he designed or he proposed self-management principles. So there are principles which if we can apply to design more innovative organizations, and also to deploy this capacity for self-organization in our institutions that would make themselves more robust and more resilient. So, so some radical transformations have to be made, but even outside our institutions, those organizations like the Chef Andre and the John Cole Social Network, they can be ruled by such principles. And they are what I call focal points of, or focal engines, or engines of social innovation generation. So how do we generate social innovation? Well, first of all, of course, you have to have a social innovator which is sparking that. But then in our institutions, we also can spark such innovation if we stimulate participation. Or what else can we do? So I've been preoccupied by this question, obviously, having felt strangled in our hierarchies at work and in academia and in our government and everywhere. And we see now that we are undergoing a revolution around the world, that we have to change and improve these structures in a radical way to change the policies with policies that empower the citizens to take action. So what can our institutions learn? This example, this can be applied to anything, but it is about e-learning and how the educational system was actually forced to innovate so quickly, and kids are so adaptive, except for, of course, the fact that parents have to take care of them and they have to stay home with them and so on and so forth. Speaking of Father's Day, I think kids are doing really well in these environments. And remember the example which I gave you with the virtual environment in which they can find themselves in the classroom. But it's something much more and much deeper going on, because now our teachers are being forced to improve themselves. because the students and the school can access any teacher from anywhere. So if I find a better math teacher, I would rather go there and work with that one, or bring that to my classroom, to my school. So education, obviously, learning is a state of spirit. That's what that's what it is. So nobody can learn anything for you, but a good teacher is really important, because in our education system, how the rules have been written, definitely it doesn't work. I mean, I don't want to start this discussion now. So remember the initial image which I showed you here? Well, this is exactly how our education system is strangling our kids. So we are, no, we don't need robots for factories or office jobs anymore. We need creative minds, but we are not allowing them to develop in the current education system. So how do we actually set the premises for resilience by starting with the education system? This is another question which is pretty crucial. From knowledge-based education to thinking-based, from long analysis to fail fast, results-oriented, initiative-oriented. Few successes well planned, many failures and successes. So, this, don't be so averse to uh, to risk or to failure, as we are teaching our kids now, that, oh, it's so terrible that you did not remember when Napoleon was born or something. So we have to allow them a bit more freedom, so they can be those agents of change and social innovation when challenges like 2020 brought upon the world will come when they are uh, mature. Coming back to institutions, well, of course, well, we probably, without knowing, we are punishing the wrong things and we are rewarding the wrong things. So that is also another important aspect in how are we fostering innovation in our organizations. This is now, taking me to rethinking organizational architecture, because all this social innovation which we have seen that can work to create a resilient world can work very well also in our institutions. And when it comes to ways of doing things, uh, on the organizational continuum, culture is structures by the conventions of coordination. So if you have a hierarchy in which you have a boss who is very tough and you cannot move, that's not really very creative, and it's not going to be an innovative organization. We know all this stuff. So how do we deploy these responsible autonomies with, I gave you the example of peers incorporated. Are we ready to adopt that in our institutions, and are we ready to take the risk? These are the control structures I mentioned. So it turns out that a really nice one is when you balance autonomy and cooperation. Obviously, you don't want anarchy and total autonomy. Elinor Ostrom has proven, yes, that people are going to destroy what they love the most if you leave them totally free, but you can guide them. So the idea is to have this pressure from the top, but also enough freedom from the bottom. And there's a whole theory about that, which is called holonics. Um, but so anyway, and there are studies which have proven that this holonic, I would call them holarchies, because they are not hierarchies, are very good to solve complex problems, while the networks, as I was mentioning before, actually are really good for solving ambiguous problems in which we actually do not know, like, if I go out, will I get infected or not? A lot of ambiguity going on right now. So networks are the best in solving that. So coming back to this capacity for self-organization, there are a few questions which, of course, it's time to pose them now. How do we use the digital environment to increase people's capabilities? How do we implement architectures of participation? So, they should have low barrier to entry, which I think they do now. I mean, Zoom is everywhere. and how do we achieve effects with resources which actually cannot control? And again, Peirce Incorporated gives some principles in that regard, as well as participatory economics, but they should become pervasive. I mean, they should be taught in economic classes. So there is this concept which Mitch Kapor has developed, which is called architecture is politics, which is absolutely true. If you look at Google and Facebook and all these centralized cartels which are preying on our data, it's their architecture that are enabling that. Now with blockchain, we can decentralize those architectures of participation, and we can let people own their data and give them and actually be rewarded for that. So architecture is politics. We are unaware of that, but that can be also used like lessons from the social network operating system as personnel platforms, in which now we can look at people to increase their capabilities via collaborative networks, like, in the gig economy, with new forms of social organization. But we still have to pay attention to how we deploy this. Like, for example, now with Zoom and many other platforms, they threatened me actually that if I do not pay for Zoom, I can't talk for 40 minutes or 30 minutes, but they are going to use my data. So I have to pay in order to keep my data, which I don't think it's fair. I mean, it's definitely not. I'm paying for the service. Okay, that's fine. But on the other side, I have to be given also the option that I get a service in exchange of my data. So this is what is happening now. These tensions are not yet resolved, and we need more regulation in that regard. So anyway, there's a lot to talk about when we design these architectures of participation. So especially this is what I was talking about here, the policies through which we unleash them. So as I was talking about from top down to bottom up, this pressure, I worked with several such hierarchies, like, for example, you have here the supply chain, and then you have factories and workplaces, and here you have the robots and so on the shop floor. And in order to, for example, if I receive an order which is totally unexpected, in order to be able to undertake it as a factory floor, I will need to quickly reconfigure my supply chain to get those materials. For example, now many car manufacturers have changed to manufacturing masks, obviously, because they are so important. And in order to do that, obviously, they had to reconfigure their supply chains immediately. So in order to do for that, this emergence of institutional norms from individual agent interactions from this, the reconfiguration of the plan here at the factory floor, it's enabled by, again, this distributed network simulation systems, which we call software capsules, multi-agent systems. But of course, that requires a PhD. But your people here with data analytics, I'm sure they know what I'm talking about. So it is, in fact, very similar to how biological organisms, as I mentioned before with John Doyle, are actually self-organizing. So the ants actually have created this path from their nest to the food source through their simple interactions, without any planning, without any outside coordination. So they didn't know where the food is, but then they self-organized in order to shorten this path from the food to the nest, so they can bring the food quickly. And this is, this capability of self-organization from biological systems, we can also make use of it in our organization. So it is this kind of things which I am mirroring, and of course simulation modelings and are being used like that to reconfigure production, as I was showing there, or a lot of other things, like from cars to masks. So if we have, let's say, this is the physical world with various entities, and then I am creating this twin of the world in digital form. These are the software representations of these physical objects. Then I can run simulations here and reorganize, recluster them. So from here, for example, this one will come and belong here. Two of them are here now. So that is how I reconfigure them. I reconfigure them at the software level, so I can make various decisions around, for example, when will I get people to work and how do I reorganize my office? Okay, so these people are not going to work here anymore, or they're going to work here. In the same manner, also, when I reconfigure production now, this robot is not going to stay here. It's going to be moved somewhere else together with others, so they can produce now masks and not cars anymore. So this is the simulation modeling which I was mentioning before. So we can use that for coordination of production and reconfiguration of production, but we can also use that similar way to coordinate and govern work, in our institutions, and let people to back to work by optimizing across, let's say, not only productivity but also health right now. So this is a sort of obviously decision making which our decision makers are making, but in a much more organic way. So we are working now with hospitals, and when I say we, I'm talking about Singularity.Net, with hospitals for clinical trials. We are very busy with that because we are involved in treatment for COVID-19. But of course, there's a lot of applications here as well. So we are using simulation modeling in hospital as well to not only for accelerating the clinical trials, for delivering vaccines and so on and so forth, but also for calculating capacity of the hospital relative to what's happening in the outside world, and for creating more capacity timely if it is needed. So it's simulation modeling in this way, in this distributed way, is very useful. It also enables more agility of response when it comes to these emergency responders right now, because the incident command structure is a top-down instrument which is not flexible enough. That's why all these disasters happened with Katrina and Harvey and so on and so forth, because FEMA reacted too slow. So now we are trying to melt this rigid structure and make it more adaptive, and itself being more resilient, so it can respond and bring resilience to the world. I think I kind of got to the end of my talk. I hope I'm within time. I didn't get my watch with me. But what I'd like you to stay with is that the new normal is definitely pushing us to find ways for agility of response through reconfigurable work processes, of course, to maximize remote work, more automation to avoid people exposure, self-organization, mirroring biological behavior, and of course, artificial intelligence, big data, and blockchain, as I try to emphasize, are crucial for the deployment of technologies that are going to keep us going in spite of all the blockages and the risks that are outside, be they COVID-19 riots, killer hornets. Let's see what's next. Thank you very much.